Welcome back, friends. We are continuing to look at fractions, and tonight we're going to be looking at comparing fractions. And our objective states, how do you use benchmark fractions to compare fractions? So I have a couple of reminders before we start. So first, I want to remind you that our benchmark fractions, or our famous fractions, the ones that are most well known, are 1/10, 1/4, 1/2, and 3/4, and all of their equivalent fractions. So we want to keep that in mind as we work, that anything that equals 1/10 or 1/4 or 1/2 or 3/4 is a benchmark fraction. The other part is compare. We know that compare means to see the difference between two things. And when we look at numbers and fractions, we use symbols to help us compare. And we use greater than, less than, and equal to. And we know that our chompers, our teeth, go towards that number that is greater than or less than. So I could say 6 is greater than 2, 4 is less than 8, 2 over 2 is equal to 4 over 4. I'm going to ask you about that one tomorrow and see if you can tell me why both of those are equal to each other, even though they are using different numbers. So we're going to look at two different strategies for comparing fractions. The first is making an illustration. And to make an illustration, we first need to take a look at the fractions that we're going to use. And we're going to start with a benchmark fraction. We're going to use the most famous fraction of all, the king of all fractions, 1/2. But we're going to use an equivalent fraction to 1/2. We're going to use 3/6. 3/6 is still a benchmark fraction because it is equal to 1/2. So we're going to be comparing 3/6 and 2/3. So to make an illustration, we need to draw pictures of 3/6 and 2/3. So I'm going to draw 2 circles. And I'm going to split my first circle into 6 equal pieces. And I'm going to split 2/3 into 3 equal pieces. So now I'm going to shade in my 3 out of 6 pieces. So I'm going to shade in 1, 2, and 3 pieces, which I also know is equal to 1/2 because this is a benchmark fraction. And my second illustration, I'm going to circle or shade 2 out of the 3 pieces. So I'm going to shade in 1, 2 pieces. Now if I look at those 2 illustrations, it looks like to me that I did a pretty good job making sure I have equal pieces. And it seems like 2/3 is greater than 3/6. So I want my chompers, my teeth, facing 2/3. So I'm going to draw my symbol right in between, and I have my teeth here to show I want that bigger piece of 2/3. So 3/6 is less than 2/3. 2/3 is our larger piece. Now our second strategy is to use common denominators. And we're going to use the same fractions, 3/6 and 2/3. And we're going to use the common denominator strategy. Now I'm going to tell you that I prefer strategy number 2. I'm going to put big stars around strategy 2. I like this one better because it's a lot more accurate to me. Sometimes, as some of you have pointed out, I do not have very good drawings, and it might be hard to make sure I have exactly equal pieces. So this second strategy is a great way to make sure that you are accurate 100% of the time. So we are going to be looking at 3/6 and 2/3. So to make common denominators, we need to do a couple of things. First, I'm going to circle both of my denominators. I have 6 and I have 3. Now I know I'm going to write my multiples, but I only have to go up to the product of my two denominators. 6 times 3 is 18, so that's as high as I need to go. So I'm going to start with my 6 multiples. 6, 12, 18. I don't have to go any higher than that. Now I'm going to do the same for 3. I'm going to write 3, 6, 9, 12, 15, 18. Now I have to circle all of the multiples that they have in common. So I see they both have 6, they both have 12, and they both have 18. Now, what do I do if they have more than one? I want the lowest common denominator, and 6 is our lowest common denominator. So I'm going to make equivalent fractions now using 6. So I can ask myself, 6 times what gives me 6? Well, 6 times 1 equals 6. And I use this same factor times 1, and 3 times 1 equals 3. Now, you might ask, why do we do the same thing in the numerator? Well, because 1 over 1 equals 1. So that means we're multiplying by 1, which keeps the value the same. Now we're going to look at 2/3 to try and make an equivalent fraction with 6. So we ask ourselves, 3 times what number equals 6? And I know that 3 times 2 equals 6. So I'm going to erase that question mark and add in 2. Now I'm going to use that same factor times 2 on the numerator. 2 times 2 equals 4/6. And I did 2 again in the numerator because 2 over 2 equals 1 whole. And that will keep our value the same. So now I have two values, 3/6 and 4/6, that I can use to compare. And now it's much easier for me to tell. I have 6, 3 is lower than 4, easy peasy. I want my mouth, my chompers headed right towards that 4. So 3/6 is less than 4/6. So now you have two strategies to take a look at when comparing fractions. We're going to be revisiting this tomorrow and when we begin next week. So take your time and good luck.